Good morning, good afternoon, good evening, wherever you are watching this from. This is Cornelius Subinda with another video. We are continuing on the practice questions for additional mathematics vectors. This is 2024, paper 1 internal, question 10. Take note that the previous video, it was question 11 for 2023, but in this year, it was question number 10. And also take note that vectors always carries 9 marks. And I just hope that you may follow as we answer together. The question reads, find the vector equation of a line through the points A, which is 3, 7, B, 2, negative 8. So, the point A is 3, 7, then the point B is 2, negative 8. They want us to find the vector equation of a line through these two particular points. And the first thing that we need to know is we just need to find the gradient. The gradient means that you can just name the coordinate. Okay, the gradient means the slope. So to answer, we just need to name the coordinates. So x2, y2, x1, y1. Any order matters. So this can be your subscript 2, this can be your subscript 1. Or this can be your subscript 1, this is your subscript 2. So gradient m is equal to y2 minus y1, you divide by x2 minus x1. So y2 there is 7 minus, alright? So 7 minus, here we have negative 8 to be put in parentheses. And then there we have a 3 minus, we have a 2 there, so no need for parentheses. This will be 7 plus 8, which is 15. You divide by, this is a positive 1, m is equal to 15, like that. And then to continue, we'll say that direction vector, because that's what we want, direction vector m is equal to 1, 15, like that. Then method 2 is where you use them as position vectors. Or A will be 3, 7, like that. Or B would be equal to 2, negative 8. The resultant vector AB would be equal to AO plus OB. That's how we always move with the position vectors. We just change the direction. Instead of going from O to A, we go from A to O and then O to B, so that we can follow the pattern of this vector here called the resultant vector. And then it will be equal to AO is negative 3, negative 7, and then OB is 2, negative 8. So if we add the top, we're going to have negative 1, bottom negative 15 as our AB. And then your final answer, so if you take notes here, both 1 and 15 are positive. Here both 1 and 15 are negative. Actually, what you can just do is you multiply throughout by a negative 1. So AB will also be equal to 1, 15. So finding this and finding this is okay. But since I already found this, I will carry on with this one. So you can use either one of the methods, but I'm just saying that if you found this answer as your direction vector and this as your direction vector, both are okay. Yes. Let's continue. So mind you, this was only carrying 2 marks. So therefore, xy as your direction vector would be equal to 3, 7, plus a t, you multiply by 1, 15, or xy is equal to 2, negative 8, plus a t multiplied by 1, 15, like that. Then we'll say our a, xy is equal to 2, negative 8, plus a t multiplied by 1, 15. So that's your A, and this would be your final answer. This would be correct, or that would be correct. Either one and not both. Don't write both answers. Just write either one of them. So that's your 2 marks there. And then B says find the value of t for which vector p is equal to ti plus 3j and vector q is equal to t squared I minus 9j are perpendicular. Perpendicular is the main thing there. So when we are hearing something about perpendicular, before we even try to start thinking a lot, we should try to ask ourselves, what do we know about perpendicular vectors in regards to the dot product or the scalar product? We know that the dot product of perpendicular vectors should give you 0. What do I mean? I mean, if we write our vector p like this, vector p is equal to ti plus 3j, and then our vector q is equal to t squared I minus 9j, we are saying vector p dot vector q is equal to 0. That's what we are saying. So vector p, we substitute these components to be ti plus 3j, you multiply by q, t squared I minus 9j is equal to 0, like that. That's what I've done. When you're multiplying vectors, you only multiply this I component by that I component. Then, so I'm meaning this part by that part, and then this part by that part. Never should you go from here to there. Always go like this. Here to there, there to there. That's how we multiply. Alright? Please take note of that one. Why am I saying that? Because I times j gives you 0. Why does it give you 0? Simply because I and j are perpendicular. I represents movement in the xy and in the x-axis. J represents movement in the y-axis. So this would be our I, that would be our j, and the angle between them is 90 degrees. And if you go to multiply I times j, knowing that the angle is 90 degrees, it would give you 0 by this property. Okay, so it would be t cubed, here minus 27 is equal to 0, t cubed is equal to 27. So here I'm only looking for the positive root, the real root of 20, the real root, only one of the roots of 27, and one of those roots has to be real. What am I saying? Just take the cube root. That's what I'm trying to say. Don't start to find complex answers, complex numbers. You take the cube root on both sides. It will cancel that cubed exponent, power 3, like that. And then t, therefore, would be equal to cube root of 27 is 3, because 3 times 3 times 3 is 27. And then we'll say b, t is equal to 3. That's your answer. If you substitute in these two vectors, you're going to find a dot product equal to 0. Then if you go to B2, so B1 was carrying 4 marks, B2 was carrying 3 marks. Take note, if you add 2 plus 4 plus 3, which is the total number of marks, it should give you 9. Right? So we have vector A being equal to I plus 7j, then vector B being equal to 2I plus j, like that. So I plus 7j, and then vector B being equal to 2I plus j, like that. They want us to find the angle between these two vectors in degrees. How do we find the angle between two vectors? First of all, we need to know the scalar product or the dot product formula, which is vector A dot vector B is equal to magnitude of A multiplied by magnitude of B. You multiply by cosine theta, like that. And then, in place of vector A, we'll substitute that, which is I plus 7j in place of vector A. Then in place of vector B, we'll substitute this part, which is 2I plus j is equal to magnitude of a vector. We get the x component and the y component. X component is the I, the y component is the j. So, and then we take the square root of that, okay? So here we have 1I. Let us just get the 1, we square it. Here we have the 7, we square it. So take the square root of the x and y component squared, right? Then you multiply by the square root of the x component here is 2I. We are going to get the 2 squared. And then the y component is just 1j, which is just going to be plus 1 squared. So you need to add those two components. And then what are we doing? Multiplying by cosine theta. Let us simplify here. We're going to have I times 2I, which is 2. 7 times 1j, which is 7, is equal to square root of 1 plus 49 multiplied by square root of 4 plus 1 multiplied by cosine theta. So this is a 9 is equal to square root of 50 multiplied by square root of, here, 5. Because 4 plus 1 is 5. Multiplied by cosine theta. Then we divide both sides by square root of 50. Don't simplify here. There is no need for you to simplify these sets. There is no need. You can simplify them, of course. You can maybe you start to look for numbers that can go into 50. Now it's a waste of time. So let's just write them. So square root of 5. You can write it like this or like this. When you write square root of 50, square root of 5, it simply means you're multiplying the two roots. So this can go into itself 1, into itself 1, into itself 1, into itself 1. Like that. All in all, we have our cosine theta is equal to 9 you divide by square root of 50 square root of 5. Okay, let's clean up so that we can answer the rest of the question. So we are saying cosine theta is equal to 9 divided by root 50, root 5. Theta is equal to cosine inverse of 9 divided by root 50, root 5. Theta is equal to, so to find the final answer here, make sure that your calculator is actually in degrees. So cos inverse of 9, we divide by, so make sure that this root 50, root 5 is in brackets. So cos inverse of 9, we divide by root 50 times root 5 in bracket, you close the bracket. Then this would be equal to 55.3 degrees. That's your final answer. 55.3 degrees. So that would be your theta. That is your theta, and that is your answer for B2. So theta is equal to 55.3 degrees. That's the end of this video. Thank you so much for the support. Thank you so much for watching. I really do appreciate the support. This has been Cornelius Subinda with another video, and bye bye.